It's time to talk about the cube, as in Cisco Unified Border Element. Now, you know my visuals, right? I'm always trying to come up with creative pictures, and I was saying, okay, what do I come up with for Cisco? Like I hadn't even finished the thought, and it's like the Borg. I mean, it immediately comes to my mind this cube battleship, and it's funny as I'm sitting here thinking I haven't seen a Star Trek episode since, well, at least since I've had kids. Which is what 6 years, so probably 8, 10 years ago. And yet, as soon as the Borg came to mind, like it was as if I was sitting there on the couch for the first time, being introduced to the Borg. And what I don't know what it is about the Borg that's just such an intriguing concept to me. To where if you haven't seen Star Trek well, come on, we're all technicians here. We've all seen Star Trek, right? But it's the concept is like this ship is like this living organism, where even the people on there, they like plug into the walls. It's strange how I get teleported back there. Very few sci-fi things, The Matrix, those kind of things. Very few sci-fi things stick out in my mind, but that is definitely one of them. So hopefully. I was going to say it'll impact. It won't. Okay, but Cisco Unified Border Element is pretty cool. It is what I subtitled the voice gateway of voice gateways. I was about to launch into what it is, but that's what we're going to talk about here is what is Cube? What is this Cisco Unified Border Element? What works with this? How does this communicate? And then how do we configure it? All right, let's unpack what Cisco Unified Border Element is. Sorry, I'm just logging into my other. So I have two computers, right? I have my recording PC, which is like pristine. I don't do anything because I got to make sure everything is always working on this. I have my normal PC behind me, email, whatever else, and it was funny because I'm really on this thing of like I need to take ownership of my time. Like technology. You get distracted with right now I'm talking about being distracted on the side tangent, right? So you get distracted with it. Hang with me. I bought in the mail. I was actually reading a Network World magazine, and I saw one of the cool toys review was a USB monitor where you can just plug in this. It's like a little flat panel screen, little USB monitor into your computer, and poof, you have like Insta second. It's like what I'm looking at it now. It's like a little 16-inch tiny thing, but no power cords or anything like that. So I'm thinking, I've got a 30-inch monitor as my main screen, and people, why do you need? I have this network monitor. I use PRTG that I always want that up. I always like seeing what's going on, and I'm like, I just need like a little. Oh, perfect. So I get this thing, and it just literally like 5 minutes ago came in the mail. I'm like, I'm unboxing it. Like in the back of my mind is my commitment to God Himself. I'm like, take ownership of your time, Jeremy. Do not. And I'm like, it's USB. The drivers are built. I'll just plug it in. I plug it in. Bam! Blue screen of my computer, and I'm like, okay, I'm listening, I get it, I'm like, but and that's where it got more sad because I had like 900 things open, so I don't even know what I lost, when you get ultra distracted and you don't save any of your work, and then it boots up and then just straight blue screen. So I just finished a system restore. So that's my sad tale. To start this off. So anyway, system restore saved me. And so now the question is in my mind: Do I plug it in again? I bet you it'll work this time. Anyway, so what is Cisco Unified Border Element? Cisco Cube is a way of defining a line in the sand of your network. So here's the idea: is you can begin to start consolidating a lot of your calling and everything through a single ITSP. So when you do that, a lot of those benefits are received when you get bulk communication going out that single point. So you can get, a large amount of calls, a large bulk, get the bulk discounts, all that kind of stuff, rather than having all your individual sites connect to that ITSP. Now, from the ITSP's perspective, the reason they give you the bulk management and the bulk, all that kind of stuff, where you get, you do a large amount of volume, is because they don't have to manage all kinds of different registrations. They don't have to consume that same level of resources to have all of these different holes open, if you will, so that all your gateways can come to them. So what the unified, there's where that word comes from, the unified border element does is allow everything to come from that single location. So essentially, let's say you've got, maybe this is your central corporate office, corporate headquarters. That's where the cube router exists, and then you've got, I'm thinking, I just talked to a guy who works at PetSmart, like a pet retail place, and they just have thousands of stores that are all connected over this MPLS network. So all these guys can connect in over MPLS. All the VoIP traffic comes in here as it goes out and then unifies over the single point. Now what this does is first off give you protocol interoperability. I mean, maybe you're using H323 dial peers back here and you convert over to SIP when you get that SIP trunk to the ITSP. It also gives you, this is the big one, address and port translations or address hiding. Again, instead of these guys all having to peer with that ITSP, and they have to maintain all those registrations, essentially they all peer with the Cube router, and Cube will hide all those addresses. It's almost like NAT, if you will, for voice, to where all the signaling, everything is translated out as if it came from here. As a matter of fact, you can even do, there's two modes of media we're going to talk about. There's media flow through, and there's media flow around. I don't know why I'm writing it now, because I'll just put through. Because we'll talk about it in just a second, to where you can have the media go through the Cube router, and at that point, it hides even the source of the media and all of that, all the RTP audio, and replaces it with its own address. Or you can have it flow around, so it can establish the session, and then this guy can kind of go around that. Obviously, not literally. You may be passing through it, or you may have a different route to the endpoint. With SIP, you can say, okay, go over there now, and that'll work just fine. It gives you the consolidated billing and CDR to where it all consolidates here. Now, keep in mind that a Cisco router out of the box, you can't type in "show me a billing report," show billing report from privilege mode, right? It doesn't do that, but it can collect that data and export it to a number of servers. I mean, just look for CDR, call detail record servers out on the internet, and you will find a bajillion of them that can consolidate all that data, and then centralize your bandwidth management to where you can put all the put the large pipe of bandwidth there, the quality of service, the high quality link there. Whereas all these other guys, I mean, they just need quality of service to the Cube router. So you kind of consolidate all that into one place. Actually, I did a consulting project recently, which was really fun with Cisco. People call it Cisco OOB. I can't say that. I just say Cisco Cube. So nonetheless, the consulting project was we were at a data center with this organization that was trying to set up hosted voice over IP. And what they were doing is they actually had all of these Asterisk servers. Asterisk, which is your free version of voicemail. Think of it like if you're a Linux superstar, you'll do great. If not, it can be painful. I mean, it's essentially a Linux build of a free voice server behind the scenes. And what they were doing is that this was, think of this as being in the cloud. It's at the data center, and they would have all their client sites where all the phones would register with the Asterisk server. Well, what they did at that point was, so all their clients were coming in here doing the Asterisk thing, getting their dial tone from that. But then they would have a link to right here is a pair of Cisco Unified Border Element routers. So all the Asterisk servers would come here, and these guys had the links up to, again, from the data center. So it was what was fun about it is these literally had 1,000 megabit per second connections, direct fiber to the ITSPs. So I mean, these were not like VoIP.ms, these little free ones. This was like a real deal ITSP, and you had fiber optic cable going from the Cube router, and essentially that would register with the ITSP, redundant fiber, and all the Asterisk servers were hidden behind the scenes. So from the customer's standpoint, they're getting phones registering with the Asterisk server. They don't know that, but that's what it's doing. And when they dial 9, essentially it comes out here to the Asterisk server. Asterisk server says, "Oh, you need to go to the Cube router, to get an outside line," and then shoo, goes straight out across that fiber to the ITSP. All the Asterisk servers were hidden to where the ITSPs just saw the Cube router. It was fun. It was it's what's neat though is with Cube. I mean, when I first heard the concept of Cube, I'm like, ooh, sounds like complex. There's a whole product line called Cube, so it must be like this big deal. Totally not. I mean, when you see the config of this, you're gonna be like, wow, that's it? It's a piece of cake. So the Cube router can jump into the codec negotiations, or it can go transparent, meaning it can do things like transcoding, where it is flipping from maybe G729 as it comes from the branch or office, or maybe an asterisk router or something like that, and it can convert over to G711 or whatever codec, back and forth. As you're doing that, it can process. Hang on. You there? Can you hear me? Testing. That was fun. So I tripped over my cord, and it has like a little breaker in the middle, and it just broke in half, and so it's back. So what was I talking about? Codecs. So to where the cube router in the middle can translate between the codecs, or it can go transparent. And what that means is it's doing all the signaling, it's setting up the call, but as the codecs are passing through it, I mean, it can still do the address hiding and all that, but it can just say, look, I'm not going to touch that. I'm just, whatever codec you want to use. And I would say usually that's better. Because as soon as you introduce this guy, bam, you're adding a ton of DSPs, especially if you want to scale that cube router to a large amount of calls. So, these guys, it's kind of like, why not distribute that load, and allow them to go direct with whatever codec and just have them match whatever the ITSP is using. Okay, so let's look at the signaling, as in what works and what doesn't. First off, when you're using Cube, all SIP to SIP and all H323 signaling works. Like, you don't even have to think about it. I mean, we talked about this when we broke down the protocols. Delayed start with SIP was where it doesn't get into the SDP, the session description packet, until after this person has answered the phone. Whereas the early offer is that it sends the SDP to negotiate the codec and the media for the call, either at the beginning, the initiation of the call, or during the ringing tone. So both of those are considered early. So you can, if you're using SIP on both sides, this side can be delayed start, this side can be early offer. You can do either or, and it works a-okay. Same thing with H323. You've got fast and slow start. Matter of fact, I don't know if we hit that one directly. When I was showing you H323, slow start is what we've talked about, to where we've got H225 that sets up the call, gets it going. Then you have your H245 exchange, where you negotiate the codecs and all that kind of stuff, and then H225 ends the call and all that, which is fine. That's the normal considered slow start. Now, if you name something slow start, obviously there's a faster one. So the fast start, what that does is combine these two phases. So the H245 becomes part of the initial H225 exchange. It's like embedded inside of those initial startup packets. So again, same thing. If it's H323 to H323, life is good. You can use fast over here and slow over here, or fast and fast, or slow and slow, or slow and fast. It all works with that protocol. This is just where you have to be careful. And honestly, I was debating whether to put it in here, because you're totally going to forget. I'm totally going to forget, within 5 seconds of talking about this, I'm going to move on and forget. Like, this is what reference books are made for. The only reason I'm bringing it up is so that you're aware of it, number one, that you have to watch out for this. And just when I was looking over some of the material and thinking of what, if I were a test writer and I just wanted to be mean, what would I ask on an exam just to be mean? And this is definitely what I would ask. I'd be like, let's just be mean. So early offer to fast start works. Early offer to slow start, again, if and I'm talking SIP on the left, H323 on the right, that works as well. Delayed offer to slow start, that works as well between the two. But where you run into trouble is where you start going with the fast start. So if we go fast start over here to delayed offer on this side, that is incompatible. I should write those in red just so they stand out. So fast start on the right to delayed offer on the left, or also vice versa, delayed offer to fast start, which I know it sounds like, oh well, that of course it doesn't work both ways, but the funny thing, you also run into an issue if you do a slow start to early offer. Okay, so if I go, I can go from early offer to slow start, so that would be coming from the SIP world to the H323. That one works, but I cannot go from slow start to early offer. See what I mean? You're gonna forget it. This is gonna be one of those things that it's just, unfortunately, root memorization. It's just the way that the protocols work when they signal that way. It just is not compatible between those two. So if you remember what works, and then just say, okay, anything else doesn't work. You should be okay. All right. Last one over here is, I've already mentioned this, so this is kind of repeat info. But the media, you can configure Cisco Unified Border Element to support either flow through, where the media flows through and is processed by Cisco Cube or Cisco UB, or flow around, to where physically it may go through. It's just the Cube router does not look at it. It just says, okay, I'm passing it right through. We actually type in the command codec transparent if that's what you'd like. As I said before, when I first heard of Cisco Cube, I thought the config would be beefy. When you in the reality, you see it, you're like, wow, that's really not much to it at all. First thing is the base configuration of the voice gateway. By default, the Cisco voice gateways deny what you could call dial pair relaying, if you will. So they deny SIP to SIP or H323 connections. It does not work. If I have like an incoming SIP call to go in and bounce it off to another device, and to configure Cisco Cube, Cisco Cube, you have to allow that. So in this picture, I don't have the Cube router. Let's add it to the mix. Let's say up here we put Cube. So this guy would need to say, okay, I'm going to allow those kind of relays. I'm going to allow an incoming SIP call to maybe, out here is the ITSP. Or whatever provider you would like to. So that would come in as SIP or come in as H323, and I'm allowing that to relay through to another H323 or SIP dial peer. We do that from, I'm undoing my cloud. We do that, or a pulled tooth, from the voice service configuration mode. So I can, I was in there just a moment ago. So I'll go voice service, voice over IP, and I can do allow connections. And right there is my SIP to SIP, or my H323, it's just, to SIP, or whatever. You can type those. You can see just variants of each other. And what I would say is a best practice, unless you had a very specific reason not to, just go ahead and copy and paste that whole block right in there to allow it all. Now, if you want to do address hiding, it's a separate command. It's again from that voice services configuration mode, right there at the top, address hiding, which hides the IP addresses during the signaling. So this guy came in as 10.1.1.1, but maybe you've got 68.5.9.33 right here on the WAN. It's going to hide that address by replacing it with its own. So think of it like a voice NAT, and that's in the SIP signaling. SIP signaling, by the way, is tricky because it embeds IP addresses inside of the actual data of the packet. So what this does is actually change the outside the IP address that you see coming from the source address, as well as the one inside the payload of the packet. Then underneath the dial peer, you have your choices. You want to do codec transparent, which means this guy, and I mentioned this before, will not touch the codec. So as it passes through here, through the Cube router, it won't touch it at all. Just allow G711 in and G711 out. No DSP resources will be used in this communication. And then you choose whether you want media flow through and media flow around. The reason you might say, well, why'd you pick that picture? It seems like you're just doing this. The reason I picked this picture is I wanted to broaden your mind. I kind of used Cube as this system going from your network to them, the outside world. But you could even use it between your own offices. I could say I want to go to this Cube router and it will hide my addresses. Maybe this is a partner company in Australia and I don't want them to see my internal signaling or anything like that. I just want them to see from the Cube router perspective. You can do that, but I wanted to show this picture because you see some inefficiencies if you configure this incorrectly. Media flow through forces all the media to go through the Cube router. Now that may mean that maybe this is an MPLS WAN. If you configure media flow through, then it's going to go up to the Cube router and then back down the MPLS WAN and then use some suboptimal routing to reach this PBX system on the other side. Whereas media flow around, that allows the Cube router to set up all the signaling. It'll make sure the call setup happens between these two devices. You can use the address hiding and all that for that portion of the signaling. But then flow around says, okay, now I'm going to connect to the IP phone directly. Well, not over the PSTN, but directly that way, so that we are using a more efficient path to get there. I can configure that on a dial peer by dial peer basis to where I can say, well, for these guys, I want to use media flow around because I want them to go direct. But maybe I've got some people right here, and I want to use media flow through on those dial peers. So any config you want to use therein will work. So Cisco Cube is definitely a simple but much needed concept. Without Cube, that I was actually brought in. I gave you that data center example where they had all those asterisk servers at the data center going to that Cube router. Without that Cube functionality, it wouldn't work because the ITSP that they had negotiated with only accepted a single registration. They were going to charge, well, I shouldn't say it wasn't going to work, but it was going to cost them quite a bit more because otherwise they would have to link every asterisk server directly to the ITSP, which was more of a cost and just more of a configuration headache. It's almost like this acts as a juncture between those two to where I can put this one set of config for them and then one set of config to reach each one of these. Incoming calls from the ITSP can be routed accurately to whatever asterisk server was there. You can tell I'm buzzing about it. It was a cool project to be able to work on. So what Cube is that ability, that junction point, that address hiding, that signaling translation. If I'm going from one protocol to another, it does it all. I showed you just for probably certification purposes what works and what doesn't when you're doing from SIP to H323 or vice versa when you choose between those two different fast start, delayed start, slow, or I should say fast start and slow start, or delayed and early start on the SIP side. So finally we looked at configuring Cube. I hope this has been informative for you, and I'd like to thank you for viewing.